Okay, so on this problem, you had to find the equation for a circle that goes through 3 points. And then find the equation for the line tangent to that circle at one of the points, 612. So what was the first thing you guys did as far as just trying to decipher what steps to take? Drew it. Plot the points. Let's go ahead and plot the points really quick. So I have the points plotted here, and hopefully it gives you kind of an idea of what that circle looks like. Now I'm just going to try to sketch it. I know this isn't going to be perfect, but the whole idea is I have a circle, something like that, and it goes through those 3 points. And so the center is somewhere here, and we want to find the equation of that circle. So first thing is, what do you need to find the equation of a circle? What information do you need?
Radius.
The radius. So we need the radius.
And the origin.
The origin? Or the center. So I knew what you meant, Kevin, but I just wanted to question your vocabulary word there. So yeah, we need the radius here. We also need what the center point is there. And if we have those two, we'll be good. So my first question is going to be, did anybody actually solve this in a way that you feel confident that you had the right answer? It was a tough one. Okay, now, between the two classes, I kind of walked around and I saw what some of you guys were doing, and it was good information. Okay, some of you guys were solving it very algebraically. There's two methods to solve this problem that I've seen, and I want to share both of those with you. So the first way is, let's think about what would happen if I drew chords between those points. So a chord between those points, like so, and like so. Okay, how can I use the chords to find the center?
We can just perpendicular bisect one.
Right, if I had the perpendicular bisectors to say this chord right here, that perpendicular bisector goes through that point, the center point.
And if you did it to both of them.
Exactly, Mitchell. So if you do it for both of them, so that would require us to find equations of those two perpendicular bisectors, which is definitely doable, and find that center point. Now, once we have the center point, is it pretty easy to find the radius?
Yeah.
Yeah, because we'd have the center, and we have 3 points on the edge of the circle. We could use just one of them to do the distance formula, Pythagorean theorem, and we'll have the equation of the circle. So let's do this method first. I'm going to bring in a picture that's a little bit more clean, though. Okay, so one way you actually could have checked your answer, this is using GeoGebra, but with GeoGebra, you can actually plot a circle using 3 points, and it'll give you the equation. That would have been kind of, I don't say cheating way, but it would have helped you check your equation. It would have gave you the equation of the circle. So I went ahead and constructed this on GeoGebra, though, and we're going to use algebra just to verify. So we have A here is 0, 0. So we have 0, 8, and we have C as 6, 12. Okay, if we want to find the perpendicular bisectors to those chords, what am I going to need first of all from those chords? The midpoint. So can I find this midpoint E? That one's a pretty easy one, right?
Yeah.
What's that point? 0, 4. So that is the midpoint between 0, 0 and 0, 8. Okay? And then how can I find the midpoint D here?
Just 36. Or 3, 10.
3, 10. So halfway between 0 and 6 is 3. And then halfway between 8 and 12 is 10. You could use a midpoint formula if you want, but we have those points. Okay, what else do we need to find those equations of these perpendicular bisectors? I have points. I need slope. So this one right here should be pretty simple. What's the slope of this line right here?
4. I mean, yeah, 4. Wait, no.
The y-intercept's 4.
0.
0. Slope is 0. So what's the equation of that line then?
Y equals 4.
Y equals 4. And what's the equation? Okay, so now what's the slope of this line right here?
Y equals.
Just a slope, just a slope.
Oh.
So we are rising 4, up 4 over 6.
So that'd be 2 over.
So that'd be 2/3, yeah. So the slope here is 2/3. So that means the slope of this line right here has to be -3/2. Okay. We have opposite reciprocal. And now we have also a slope here of that line, and we also have the point. So what would my equation of this line be then? Y equals -3/2 parenthesis point slope form x minus what? X minus 3, and what goes at the end? Plus 10. So there's my equations for my two lines. Those are my two perpendicular lines. So now I don't want to make this all about algebra, but if you took those two lines, you can graph that in your graphing calculator pretty easily, right? And once you graph those, you'd have your center right there with the intersection point. Center is 7, 4. All right, now we have our point, our center point, which is 7, 4. And we want to find the radius here. So to find the radius of our circle, I'm going to go to, you can go to any of those 3 points, but the easiest one to work with would probably be which one? 0, 0. So if I go the radius there, I'm going from 0, 0 to 7, 4. So how would I set up an equation for that radius? Go ahead.
Wouldn't it be a lot easier just to do 612 just because of the next step?
You could do 612 or 0, 0, but I would just use Pythagorean theorem like Kyle just said. So it's just distance formula, right? So if we go square root of the distance between 0 and 7 is 7. So 7 squared. Plus the distance between 0 and 4 is 4 squared. And we can do a little simplification there when we get square root 65 as our radius. So now we have our radius. We have our center. Let's finish it by finding our total equation. So how would I write that equation for that circle?
Y equals x minus 7 squared.
So x minus 7 squared
Plus y minus 4
plus y minus 4
squared.
quantity squared equals 65. Because square root 65 squared, right? Radius squared. And there is our equation of our circle. So again, that first method I do like because you're only using straight lines and the ideas of perpendicular lines and slopes and point slope form, all stuff that's, you know, something that you've been doing. Here's a way you can do it that may or may not be easier, but I wanted to show you, get you an idea of how I did this, because I didn't see that way right away. So I have the general form of a circle. So let me do this. Give me a little bit more room to work. Okay, so I have my general form of a circle, which is x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, I have 3 points, and the one way that the one reason that I looked at this method was because I saw that we had points with zeros in it. When you have points with zeros in it, it kind of starts to cancel some stuff out algebraically. So I actually substituted the 3 points in and made 3 equations. And it kind of sounds complicated at first, but basically what I did is I said, okay, I'm going to take 0, 0, and I'm going to plug it in there, and I'm going to get 0 minus h quantity squared plus 0 minus k quantity squared equals r squared. And that actually simplifies nicely. I should put this whole thing, not just that part. This whole thing simplifies nicely to h squared plus k squared equals r squared. Then I substituted in 0, 8 into the same thing. So now I have 0 minus h squared plus 8 minus k squared equals r squared. And that will simplify to h squared plus 64 minus 16k plus k squared equals r squared. So now I have these two equations right away. I can do another equation. I'm going to hold off on that for a second. I can do another equation with the last point, 612. But what do I know about both those equations? What are they equal to? What are both those equations equal to? You have h squared plus k squared equals r squared, h squared plus 64 minus 16k plus k squared equals r squared. R squared. So they're both equal to r squared. So if they both equal r squared, what can we do with them? We can set them equal to each other, right? And it sounds really complicated right now. You're like, oh my gosh, these are a ton of h's and k's and squareds. And had I not had the zeros, I would have been afraid to do this. But what I mean is that it actually works out a lot nicer. Oops. It works out a lot nicer because I have all these zeros with the x's and y's. Because this looks kind of messy, but what happens when I subtract an h squared from both sides? Cancels out the h's, h squareds. What happens if I subtract the k squared from both sides? The k's are gone. So now I end up, if I do a little bit of algebra here, 16k equals 64. What does k equal?
4.
K equals 4. I have what k equals right away. Okay? And so I have what k equals now. And now I'm going to bring in my third equation because my third equation was a little bit messier.
Wouldn't you automatically know that it's 7 though? Because you could just do the first chord that goes from 0, 0 to 0, 8. And so you know that perpendicular is going to go over.
Oh, so what you're saying is go back to the previous method, use the chord that was vertical, and then you could have the perpendicular bisector of that chord, and you can find out that was 4, right?
And 7, 4.
And then we could get 7, 4. Yeah, you could probably do that if you were working both methods. Once I started doing this, I was like, okay, this is the method I'm using. I don't know. I wasn't even thinking of the other way. So once you have k equals 4, then what you can do is look at your last equation you had here at the 612. 612, we would have 6 minus h quantity squared plus 12 minus k quantity squared equals r squared. Okay, and I'm going to simplify this a little bit further. So we have 36 minus 12h plus h squared plus 144 minus 24k plus k squared. And I'm not even quite sure if I needed to do that or not. Because now that I think about it, I could just sub in the 4 right here. So let me do that. Why did I even use that step? I just did that before, so I figured I had to do it again. Okay, so if I substitute that 4 in here, I would get 6 minus h quantity squared plus, well, 12 minus 4 is 8. So 8 squared. And I know that equals, because that equals r squared, I can go back up here and go that equals h squared plus, well, k was 4. 4 squared. So I basically take the two equations, plug the k back in. Now when I simplify this back out, I get the 36 minus 12h plus h squared plus 64 equals h squared plus 16. What happens to the h squareds? They cancel out. And I'm just going to do some quick algebra here. You'd end up with a negative 12h equals negative 84. So what would h equal? And you should already know this from before. 7. And now you have your center point. Okay, now at this point I would use my center point, 7, 4. So my center is at 7, 4. I would use that point and then another point, you know, one of my other circle points up here to get my radius and use the same thing. Okay, and then at the end, it would still have that same answer, and I'll write that down here just in case you forgot. It was x minus 7 quantity squared plus y minus 4 quantity squared equals 65. Okay, now, yeah, I just showed you two methods for solving that. I prefer the first method, now that I've done both of them. Okay, anybody prefer the second method better? Yeah, shaking her head. Yeah, that's a lot of algebra. So I prefer the first method, and I definitely will have this on a test. We didn't even talk about the second part of the question, which was the tangent to that line. So let's see if we can do that rather quickly. So now the second part of the equation, or the question, was to find the equation of a line that's tangent to the circle at 612. So I'm going to draw a quick sketch here. I had my, well, first of all, I have my equation already. So let's use that. I'm not sure if I'm going to use that or not, but I definitely, it might be helpful. Okay, so now we want to find the equation of a line tangent to that circle. So any ideas of how we want to do that? We kind of already started with the idea of tangent lines. We had chords. What do we know about the tangent line and the radius from the center?
I get this tangent line and the other tangent line mixed up so
Yeah, the tangent and the right triangle versus the tangent of the circle. Yeah, that's, and you just have to work with figuring out the difference between the two. But yeah, this is a tangent to a circle. It's a line that just touches the circle in one spot. So let's bring our picture back in. So here's our picture right here, and I want to find the equation of a line tangent to C. And I can't tell if C, I don't think it's perfectly flat. It kind of looks like it's more like that. So I want to find the equation of a line tangent to the circle, which just touches it at that point C. Okay? So what do I know about that tangent line and this radius? They're perpendicular. So they're perpendicular. Now, we have that tangent point, that is 612. We have this center, which is 7, 4.
So you just go down 8
Do you know for sure that's
over
right angle?
1.
Mm-hmm.
Oh yeah.
Yeah, so yeah, the slope of this radius equals down 8 over 1, so negative 8. So what's the slope then of the tangent line?
Or 1 over 8.
Right, so the slope of the tangent line would be positive 1 over 8. And we have a point, and we have a slope. So let's just do this quickly. What would be our equation of this line? Y equals
1/8
1/8
x plus, or yeah,
x
plus 6, right?
minus 6 plus 12. Done. So once you draw a picture, it makes it a lot easier.